am delighted to introduce Leonid Smolyansky, who is VP of SoC Architecture at Mobileye. Welcome, Leonid, and thank you so much for joining us today.
Thank you.
Well, let's start maybe. Can you share with us your views on the importance of standardized solutions in the automotive industry and how actually A-PHY fits to them?
Sure. So there are a few aspects related to this importance. One is interoperability. For example, we can have a serializer from one vendor and a deserializer from another, or you could change both of them with minimal effort of both software and hardware validation related to that. And in this case, the obvious winners are ADAS SoC vendors, SerDes vendors, tier ones, and so on. The other aspect is platform cost. The ADAS system may include more than 10 different camera sensors, and such as the total number of related serializers and deserializers would be more than 15. Obviously, a healthy standard based on healthy competition, would reduce the cost of SerDes components and the overall system cost, which means winners would be tier ones, OEMs, end users.
Okay, so actually, I think if I join the dots together here as well, it's as though what you're saying is the fact that the standard brings with it an ecosystem, which of course offers that interoperability and helps to reduce hopefully overall system costs as well. So it's ecosystem, yeah, I think I would definitely agree with that. Now we're aware that A-PHY provides near error-free links, offering an unprecedented packet error rate of 10 to the minus 19. And I'm sure for some that might be just a nice bonus. But I can imagine that for a system like Mobileye that makes essentially life or death decisions based on that data, that becomes mission critical. So can you give us an example of what an error could actually cause in an ADAS system?
Sure. So there is a parameter named MTBF, the mean time between failure, and the expected MTBF in ADAS system is very demanding. It's about 10 million hours without a safety critical error. And this very significant demand makes also the corresponding requirements to underlying system components, including the long reach link to the camera sensors. So this drives very high requirements for reliability of sensing system and low error rate of A-PHY enables this in relevant sensor link interfaces.
Understood. Now you mentioned a number that you mentioned 10 million hours. So can you also share your views on the expected lifetimes of these sort of systems, and therefore the importance of guaranteeing the performance of the link over that vehicle lifetime?
Sure. OEMs dictate and expect the lifetime of the system to be at least 10 years. Usually it's more than 10 years. And this is without any degradation of performance and reliability, and in a very harsh automotive environment.
Of course. And that is basically, if you like, an end-to-end limitation with no degradation of the performance. So it's the link, it's everything that's related to that particular functionality with a minimum of 10 years life expectancy, minimum. Okay.
Yes.
Now maybe linked to this is the fact that I understand that the A-PHY itself does not require manual tuning of the silicon to the cable channel, to the connectors and to the cables themselves. Now, in terms of the integration of the systems or the manufacturing and the maintenance of the system and the maintenance of the vehicle, how significant do you think that is, that there is no manual tuning of the silicon required?
Right. Well, this is very, very important for component vendors, like Mobileye, for example, and also like service component vendors like Valens. It's important for tier ones and OEMs because it saves very significant efforts during the ADAS system bring up, and also during the maintenance of such a system. And obviously, it also improves the reliability of the system as a whole.
So if I take that back to the 10 years minimum expected lifetime of the vehicle, so if the vehicle needs to go into service and the A-PHY link needs to be replaced, the cable itself needs to be replaced, what I'm hearing here is that actually that should work automatically. If the cable degrades over time, the link will not fail. The A-PHY actually has a mechanism inside of it to deal with such changes, correct?
Exactly.
Okay, understood. Okay, so one more question for you, and I guess maybe this is the million-dollar one. Where does all of this feature in your roadmap? I mean, roughly, when can we expect to have IQ reference platforms from Mobileye with A-PHY bridges on them?
Okay. So Mobileye platforms will support MIPI APHY connectivity starting from Mobileye IQ5 family of devices. And this is now. And the ultimate plan is to support this beyond with further oncoming next generation ICs from Mobileye. We expect the A-PHY based or A-PHY supporting bridges to be available in the market as engineering samples during this year, and initial production in next year, 2022. And the IQ reference platforms are flexible and modular to adopt the new A-PHY bridges or service devices in a short time frame right after the moment they will be available on the market.
Wow. Okay. That's first of all, thank you for sharing that with us, and I'm sure to those listening, that's a very exciting piece of news. So again, many thanks for sharing it. Okay, Leonid, we're out of time for now. So thank you so much for a very interesting update and for sharing your views. I really do appreciate you taking the time today to talk with us.
Thank you.
We are proud to introduce this demo video showing the extension of CSI2 over Valens chipsets that support the various requirements of the new MIPI APHY standard. Let's take a high-level view of how this is going to work. As you can see in this diagram, we're going to be extending a CSI2 data stream through Valens modules and displaying the results on two different ECUs. All right, let's start at the beginning. A CSI2 data stream from an 8-megapixel Sony camera. Now, in order to extend this data stream, we're going to connect the camera to MIPI APHY standard chipsets. As these are still currently in development, we'll show you how this works via a proof of concept. An existing Valens automotive PHY paired with an FPGA. So we connect our VA7000 modules via one coax cable. I should mention that the cables can be up to 15 meters long with up to 4 inline connectors. Let's check out the results on the far side of the cable. We've connected the module to 2 ECUs. The first, the Mobileye IQ5 SoC, displays a log of the packets as they are being received and shows the configuration of the sensor. The other ECU displays the extended CSI2 data stream in video format. Thanks to our adaptive noise cancellation and ultra-fast PHY-level packet retransmission, Valens automotive technology guarantees that all packets are delivered error-free across the link, even under the harshest of automotive EMI conditions, with a link latency of only a few microseconds. While this proof of concept demonstration utilizes Valens automotive PHYs, it proves an insight into the capabilities of our upcoming MIPI A-PHY devices. Valens is already designing its first A-PHY chipsets that will enable the extension of CSI2 over MIPI A-PHY. Our upcoming VA7044 and VA7042 deserializers support connectivity of multiple CSI2-based cameras, radars, LiDARs and other sensors, or act as a zonal sensor hub featuring 4 or 2 independent receiver links with speeds of up to 8 gigabit per second each. Both chipsets will support up to 16 CSI2 virtual channels and will be compatible with any standard A-PHY serializer, including those integrated into sensors. Valens will also be offering 2 discrete serializers, our VA7031 running over an 8 gigabit per second A-PHY and our cost-optimized VA7021 running over a 4 gigabit per second A-PHY. MIPI A-PHY solutions are designed to meet the needs of future AD car networks, supporting complex topologies, high bandwidth and strict safety requirements. Engineering samples of our VA7000 family chipsets will be available later this year.